Hi, I'm Tyler Albee,
And I'm Shawn Polson.
and this is our data mining project.
A little bit of a brief history of our project before I let Shawn get into what a stealth coronal mass ejection is. Our story begins with Shawn. Now, Shawn works at LASP. He reached out to the scientists at LASP to say, what's going on? How can we help? And that led us to our subject matter experts, James Mason and Don Woodruska. Now, James Mason is a CU graduate. He used to work at the University of Colorado Boulder. He now is a NASA postdoctoral program fellow. Now, James is the one who helped us with the vast majority of our code. Don Woodruska, our CU expert, helped with coordinating with James as well as getting us the data we need.
So really quickly, a stealth coronal mass ejection is just like a normal coronal mass ejection, or CME, pictured here on the right, except that it's not preceded by any other solar activity like a solar flare, pictured here on the left, hence stealth. Our data set comes from the instrument out in space maintained by LASP, SDO-EVE. That stands for the Solar Dynamics Observatory Extreme Ultraviolet Variability Experiment. And on board the SDO-EVE instrument in space are a couple spectrographs, which, to put it shortly, splits up dots of light into its component wavelengths, which allows scientists to study how the various parts of that body change in different wavelengths. Shown here is a snapshot of our pre-processed dataset. Every row is a measurement from the SDO-EVE instrument taken at a time. They take one measurement every minute. And each of these attributes here is a specific emission line in the sun, and these numbers are irradiance values. And the idea is that you can detect stealth CMEs and regular CMEs, for that matter, in the data by looking for spikes in the irradiance values, shown here in the red, and a signature of a CME is that there is some dimming afterwards, as shown here in blue.
The questions we sought to answer in our project were, what percentage of CMEs listed in the SOHO catalog are likely to be stealth? How can we characterize stealth CMEs based off of their dimming profiles? And what is the risk of a stealth CME damaging Earth's technology?
To learn what percentage of our sun's CMEs are stealth CMEs, we consulted the SOHO catalog, which is a catalog of CMEs maintained by NASA and the European Space Agency. It's shown here. It contains information on CMEs all the way back from 1997 until the present day, but it notably never had this stealth column. This was one of the largest results of our work. We label each CME as stealth or not with some uncertainties, and we have given this data set to our subject matter experts for further study. We estimate that about 32% of all CMEs are stealth CMEs.
To characterize our stealth CMEs based off of their dimming profiles, we needed to look at three different characteristics. We needed to look at the dimming duration, the identified slope, and the depth of each stealth CME. To do that, we wrote a Python script that would detect all of the stealth CMEs in the SOHO catalog. For each stealth CME, we're going to be returned the depth, the identified slope, and the dimming duration.
Finally, to understand the risk of a stealth CME damaging Earth's technology, we needed to know A, how many of them exist, and B, how powerful they are. Our Python scripts have detected about how many stealth CMEs there are, and we have a script that will return all of the dimming characteristics for those stealth CMEs. And combining the information can give us a true understanding of how risky stealth CMEs are.
We knew that this was an ambitious project from the start. We're not fully satisfied with our results, but our true goal was just to work with real scientists in the field, to learn their methods, and to do our best to advance their work.
And we can proudly say that we accomplished that goal. When we first reached out to Don at LASP, he warned us that we probably had an 80% chance of succeeding. In the end, we were probably 80% successful.
And during the course of the project, we gained an in-depth understanding of the data mining techniques used to accomplish real space science. We applied those techniques and came up with probably the world's first approximation of how frequently stealth CMEs occur.
And that was our project.